Hello, this is David Batty, and this is my presentation into my report on the relationship between leg dominance and ground reaction force. Now we're going to go into a bit of an introduction into the topic and explain what we're looking at and why we're looking at it. So as you can see, many sports do involve jumping, cutting, and landing of some sort. Now, in a study in the US of collegiate athletes, as you can see, over a 16-year period, over 50% of all injuries were done to the lower extremities and lower limbs, so ankles and knees. The next most common was upper extremities with arms, wrists, and elbows. When we're playing sport, one of the most vulnerable times for injury is when we're landing. So there's a lot of force that has to be actually dispersed when we land so as not to actually be injured. Research has shown that a favoured leg can actually change the chances of injury. Now, a part of this, some of the research has shown that there has been an increase of injuries to the dominant leg. Now, this is the leg that you would use to kick, jump off of. It's your favoured leg. Now, the first few studies on this actually showed quite a large increase, up to 92.3% chance of increased injuries sustained to dominant legs. Now, most of these injuries were related to ankles and quads. Two studies that actually show a completely opposite reaction. One was actually into female alpine skiers that showed that the chance of ACL injuries actually was increased, and all ACL injuries that happen on the slopes, 63% of anterior cruciate ligament damages were done to non-dominant legs. Another study showed that soccer players, that 55% of all soccer player injuries over their career were done to their non-dominant leg compared to 35%. Now, as you can see, all of these studies seem to contradict or contrast each other. There's also been just as many studies that have shown that neither dominant nor dominant leg have a higher increase of injury. So as you can see, the discussion has been set that dominance doesn't seem to actually be something that we can quantify as to why or why not people are actually getting more injuries. So that opens up the question of, is there a difference between dominant and non-dominant legs when it comes to impact, and does leg dominance therefore increase the risk of injury? In our study, we're aiming to investigate the impact of dominant and non-dominant legs from a small drop and investigate how these can be related back to earlier studies of both injury and impact. As you can see, the study involved 21 apparently healthy adults. They were mixed in gender, age, height, and mass. All the participants were asked to actually complete a health screening form before commencing to make sure that we knew about any pre-existing conditions. That was followed up by an explanation of what exactly was going to be taking place in the testing. Informed consent was then obtained from each of the participants. The participants were then asked about their dominant leg, which leg that they would actually use to kick a ball the furthest. A little bit of a rundown of what happened on the day. We set up a 30 centimetre box in front of a force plate. Now, the force plate was built into the ground to make sure that we didn't have any slips or any problems when it came to landing. Participants were then required to have a look up and pick one of two identical pieces of paper to tell which leg that they would start their testing on. Participants were then instructed to stand up on top of the box in an anatomical position with their feet flat on the box, toes at the front edge, arms by their sides, and palms forward. Each of the participants then had to raise one of their legs up to 90 degrees, count down from 3 to 1, step off the box onto the force plate and land smoothly. Each of these tests were done with both shoes on and shoes off, and the shoes on was collected first. Here's a bit of a description of the people that came in. And here's a description of what actually was shown up in our results. Now, all of these are done in multiples of body weight. So what we've done is we've looked at how the ground force reaction actually related back to times the amount of body weight on landing. Now, as you can see, that's actually quite high, 3.56 with shoes on and 3.90 on dominant leg. So that's almost 3.5 to 4 times their body weight as they land. You can see how this could actually increase chance of injury. So as stated earlier, the study that we were looking at was to investigate the difference of impact of dominant versus non-dominant legs and what that could relate back to injury. Our findings actually showed that there wasn't really much difference between the impact of dominant and non-dominant legs from that 30 centimetre drop, which runs similar with a couple of other studies that I can show you a bit later. This doesn't actually eliminate the fact that one leg may cause an injury, and there are some merits into the idea that this might be so. Okay, so now we're going to talk about a couple of reasons why injuries might happen to dominant or non-dominant legs during sports. The two research papers that I looked at for non-dominant leg injuries, the first one actually was to do with soccer. Now, the injuries to the knees of non-dominant legs in soccer are usually attributed to that being their plant leg. So whilst they're kicking, all the force on their leg, as you can see in the photo, is going on weird angles and things like that. So if they ever get bumped or moved or anything like that, that heightens the risk of injury. The other one was alpine skiing. So this is where we've got to look at whether the leg is strong as their dominant leg. So this might need further research into measures of strength or even just circumference measures to actually see whether that leg is just dominant with strength or non-dominant with strength rather, and that whether that was making it more prone to injury. The research showing that the dominant leg was more likely to be injured, actually most of those came with sports where they were landing or cutting. So when somebody's landing or cutting, they quite often will favour a leg. So it might actually be the repetition of actually doing that movement rather than the impact related to anything that they're doing. So in our study, though there was no statistical difference between dominant and non-dominant legs, I believe that there needs to be further measure of these landings and maybe even a few different measures that will actually help us to actually determine whether dominance is actually a cause for injury. Now let's look at a couple of practical implications of the study and the research that we have been looking at. The incidence of injury in dominant and non-dominant legs may be better explained by the amount of times these movements are done rather than leg preference. Training in the use of the alternate leg for landing, whether it is their dominant or non-dominant leg for kicking, landing, jumping, may actually then reduce the load of those limbs and reduce the chance of injury. Though this study has shown no significant difference in the ground force reaction, that means that the chance of injury is probably going to be put down more to that overuse and higher chance of injury in specific sports. Here are the references used throughout the presentation. Thank you and goodbye.